So today I'll show you how to make a dodecahedron, the quintessential platonic solid here in SpaceClaim. It's important to point out that this will also show a number of nice modeling techniques for moving geometry to different places and so forth. I'm going to start off by making a pentagon. Now we can do this using, in 2007 Plus, using the new polygon tool, but that's kind of cheating. So I'm going to show you how to construct the whole thing using, basically a straight edge and a caliper, just like you did in geometry class. And so you may recall the way that we construct a pentagon is we create a circle with a line there, and then we'll create another circle from the midpoint of that line to the top of the first circle. And then we're just going to set our calipers here to the distance of that intersection down to the left side of our new circle. This is now the length of one of the sides of a pentagon inscribed within our first circle. You can see we can just snap on to the length that we set up, the radius of that first circle. We'll tick off another one here. And we'll make this line a mirror line just because it'll make things a bit faster here for us. So draw the sides, snapping to those intersection points. I have grid snap turned off so I don't accidentally snap to a grid intersection. And now we have a pentagon. We'll just make sure we did it right using the measure tool. All those sides are the same length, which is what we were hoping for. And now we have a regular pentagon constructed the hard way. Now, the trick here is we'll make another copy of this face to try and get the second face of our dodecahedron. And I'll swing this guy over. The key is, what should that angle be? And I suppose if you wanted to be real, you could do it using trigonometry, but that would be cheating. So what we're going to do is construct it. And the key observation to make is that there's symmetry here, and that if we look at this plane, what we're interested in doing is rotating this pentagon to where its edge there on the right is touching that plane. And there are a couple different ways to do this, but I'll show you what I think is the most enlightening, which is if we rotate that out into a solid and then chop it here, you can see that we've now constructed a straight line at exactly the right place, right where that swept volume intersects that plane. And I'm just going to take that pentagon in the back, and this is a useful technique. I use it all the time, which is to put part of my model into a component and then use assembly techniques to get something exactly where I want it. So we'll make those two edges coaxial with each other, and then I'll grab that edge and snap it up onto there, and now we can hide our solid, and we have these two faces at exactly the right angle. So from here on out, it's all downhill. We can combine those two guys together. We'll take advantage of the plane we have here and start mirroring. And you can make the rest of the model by mirroring. So now we've got three. I'll set up another plane. You can make a plane through any line and face. So now we've got this one, mirror again. That gives us two more faces. Now, it's creating these mirror associations as we do this, and one of the nice things about SpaceClaim is that it's safe to get rid of them. We don't really need them anymore, so we'll delete them. Create another plane here, and another mirror, and we're almost done. Let's see. Put one more plane in here to get rid of the other extra bits. You notice how SpaceClaim is already automatically merging all the coincident geometry for us as we do it. And we're left with one face. Of course, another mirror would take care of it, but just to do something a little different, I'll grab that loop and use our fill command, which gives us our solid. And that is a regular dodecahedron. Of course, we can check the length of these edges and make sure that we didn't mess something up, but they're all about the same, and I guess you could show more decimal places if you're really worried about it, but this is correct. So once you've built your regular dodecahedron, you can construct other members of the icosahedral symmetry group, such as the icosahedron, which is the dual of the dodecahedron. It has the same number of vertices as the dodecahedron has faces, and vice versa. I think they have the same number of edges. This is the icosahedron, which is what you get when you chop the corners off of either an icosahedron or a dodecahedron. And if it does a Latin dance, you get the rhomba icosahedron. This one is actually a little bit tricky to construct, but you can do it correctly so that you have real squares there from the others. Otherwise, you can just do it using chamfers to get a feel for it. This is our truncated icosahedron, also known as a soccer ball or a buckyball, carbon 60. We've got these other ones where you take the faces and you kind of mush them in. This is the great icosahedron, and then we've also got the great dodecahedron, which is nice because it has these pretty stars all the way around. And these stars come up in some other cases. One of my favorites is the ditrigonal dodecahedron. You have to cut those little flutes out all the way around, just at the right angle to get stars. That's relatively easy to make, actually. When I do these, I typically make it on one part and then chop it up and mirror it to get it everywhere else. So here's our small stellated dodecahedron as well as our great stellated dodecahedron. And the trick is not to just sort of extrude those triangles out and draft them, but to construct them from other faces of the dodecahedron. You can see there are shared planes between the different faces of the stellations. This is one of my favorites. If you embed 5 tetrahedra into a dodecahedron, all with the same handedness, you get this pretty guy. You can also mirror this to get a more symmetric version, but I think this is much more compelling. So there we are, exploring the group of icosahedral symmetry, starting off with no other tools than really the 3D equivalent of a straight edge and a compass, and you can make a bunch of great stuff. So have fun. If you want to get started yourself, I suggest you begin with a tetrahedron and work your way up. Good luck.